take a look at graphing rational functions. So why don't you pause the video and see if you remember how to divide. So hopefully you remember x times something gives you x squared, so that's x. We multiply it out, so we have x squared plus 2x. We subtract both of these, so we have 3x. We bring down the 6. So x times something gives us 3x, so that's positive 3. 3 times x, again we're multiplying it out, and 3 times 6, so our remainder is 0. So today we're going to look at rational functions. So a rational function is of the form g of x and over h of x, where they're polynomials. So we have some string of maybe x plus 1 or x squared plus 2, but we have this fraction here. Now our parent graph is 1 over x. And if you guys remember, here's the start of our parent graph, and the asymptotes are at y equals 0 and x equals 0. So we have this dashed line right here that it doesn't cross, x equals 0, and this horizontal one at y equals 0. Well, the y-intercept, so of the coordinate 0, comma, some y value, well, 1 over 0, we can't have this, so there's no y-intercept. In the domain and range, well, it's all reals for our domain. As we go across, we're always hitting the graph except right here, except x cannot equal 0. In our range, once again, it's all reals because from high to low, there's always a spot on the graph, except y cannot equal 0. So let's say we were to sketch a graph of this. Well, what do we know happened? We know this moves it to the left 3, and this one moves it down 2, and that negative 2, that's multiplied by something. So let's start by dashing in our asymptotes, 1, 2, 3. And so our asymptotes, we know it's at x equals negative 3 and y equals negative 2. It matches those shifts. And now let's see our y-intercept. So 0, comma, some y value. So negative 2 over 0 plus 3 minus 2. So we have negative 2/3 minus 2. So negative 2 and, 2/3. So we have 0, negative 2 and 2/3. And I'm really having trouble with that fraction there. So 2 and 2/3. So we know we must have the swoop must go right here. Now as for our domain and range, once again our domain is all reals except x can't equal negative 3. And our range once again is all reals except y cannot equal negative 2. So now we're going to take a look at these, and you'll notice these have x's on top. So I've brought these up on the calculator here. So here's the first one, yep. So x over x plus 3. Well, it looks like there's an asymptote at negative 3 and 1. So our vertical one would be x equals negative 3. Horizontal, y would equal 1. Well, our domain again would be all reals except x can't be negative 3. Our range is all reals except y cannot be 1. Our next one, x plus 1 over x minus 3. 1, 2, it looks like it's at negative 3 and 1 again. And so those would be the exact same. Let's see the 2x. 1, 2, it's at negative 3, but this one it looks like it's at 2. So again, it'd be all reals, except x can't be negative 3. All reals, y can't be 2. And that last one, 2x minus 1, well, it looks like we got negative 3 and 2 again. So those would be the exact same. Well, let's see. What do we notice about the horizontal? And I'm going to put vertical as well. So our verticals are pretty easy. Those ones going up and down, those x equal ones. We found that from the denominator, so that's where our denominator is 0. But what about those horizontal? Those y equal ones. Well, when we look at our chart, it was 1 or 2, and I notice that there's a 2 here, and there's a 1 here. So that term is called the leading coefficient. So that came from there. What do you notice about the domain value of the vertical asymptotes? Well, it's not included in the domain. So we're going to do a summary of horizontal and vertical. But we've looked at 2 types of rationals. We've looked at the ones that are 1 over x with shift. And then we've looked at the ones with x on the top in the numerator and x in the bottom. And these are pretty easy. You've done this before. The vertical is when there's a 0 in the denominator. And the horizontal, it matches the shift. That up-down shift. Now it's a little trickier when there's x's on the top and on the bottom. The vertical is the same, where it's a 0 in the denominator. But for our horizontal, what we have to do, and we're going to get into this more tomorrow, is we noticed on here it was that 2 and the 1. What we have to do is we have to look at degrees. Look at the highest power. In the numerator and the denominator. And if the numerator equals the denominator, it's pretty easy. It's y equals the leading coefficient over the leading coefficient. Oops, I can't spell, I'm sorry. So, you know, if it was 3x squared plus x over 2x squared plus 1, it would be at y equals 3 over 2. If the numerator is less than the denominator, it's pretty easy. It's at y equals 0. So if we had x squared over x cubed, it's just the degree is less, so it's automatically at y equals 0. So the last couple we're going to look at. Sketch a graph, find the vertical and horizontal asymptotes, and I'm going to add the y-intercept. So let's see. Well, where's our vertical? We look in our denominator. So where does 2x minus 4 equals 0? Well, when x equals, add 4, divide by 2, so when x equals 2. Where's our horizontal? So we look at the degrees, and they're the same degrees. So it is at y equals 1/2. In our y-intercept, that 0 comma y value, let's plug in 0. 0 plus 1, 2 times 0 minus 4. So we have negative 1/4. So we can graph this. We got 2, 1/2, negative 1/4. So there we go. So our domain here, it's all reals, except x can't be 2. Our range is all reals, except y can't be 1/2. And the last one again, what are the vertical and horizontal asymptotes? So our vertical, we look in that denominator. So where does x minus 1 equals 0? At x equals 1. The horizontal, we look at the degree, and it's the same. So it's at y equals 2 over 1, or 2. So again, if we wanted to graph this, there it is, and let's find where our y-intercept is. 2 times 0 plus 5, 0 minus 1, so it's at negative 5. So it must, swoop down like that.